Let us settle in before learning Pandas. Mastering Pandas, DataFrame Basics and Operations. Welcome! In this lesson, you will learn essential Pandas DataFrame skills. You will explore, clean, and analyze real data. By the end, you will be confident using Pandas for projects. Let us begin. Running the cell now. What can you already do with Python lists? It is best to hide warnings so our notebook looks clean. We are making sure that any warnings from Pandas or other packages do not clutter our notebook. We import the warnings module. Import numpy as np. We set the random C to 42 for reproducibility. We tell Python to ignore all warning messages. Running the cell now. This code sets up our environment by importing essential libraries, fixing randomness for reproducibility, and suppressing warnings to keep our notebook tidy. While it produces no visible output, these steps ensure consistent results and a cleaner workspace, laying a solid foundation for effective DataFrame exploration and analysis ahead. This dataset is popular for learning and shows real passenger records. Data setup. Titanic dataset. You will work with the Titanic passenger dataset. Let us load and preview the data. Running the cell now. Imagine trying to predict who survived based on the details in this data. Let us get started with real data. We add a comment so we know this cell sets up our data. We import Pandas, which is our main tool for data analysis. We point to a public web address where the Titanic CSV file lives. We read the CSV file into a data frame called df. Now all the data is ready to use. We print the number of rows and columns. This tells us how much data we have. We look at the first 3 rows to see what the data really looks like. Running the cell now. This output shows the initial shape of the Titanic dataset with 891 rows and 12 columns, confirming we have passenger-level data with multiple features. The first 3 rows preview key columns like passenger ID, survived, P-class, name, sex, and age, helping us immediately understand the dataset structure and what types of variables will work within the analysis. This step ensures our data loaded correctly and sets the stage for deeper exploration. Try changing the number inside head to see more or fewer rows. Let us look under the hood of our Titanic data frame. This comment helps us remember the goal of this cell. We print all the column names, which are the properties for each passenger. We print the index, which tells us how rows are numbered. We print the data types. This shows which columns are numbers or text. Running the cell now. This output shows the Titanic dataset structure, listing all 12 columns and their data types along with the index range from 0 to 890, confirming there are 891 rows. Notice the mix of numerical, int 64, float 64, and categorical, object, columns, which helps you understand what kinds of data you'll be working with and guides your next steps in cleaning or analyzing the dataset. This foundational overview is key to preparing for efficient data exploration and manipulation. Which columns do you think are most helpful for survival analysis? Now, let us get a statistical overview for the numeric data. The comment gives a quick summary of what we are about to do. We use describe to see statistics like mean, minimum, and maximum for each number column. Running the cell now. This output gives a summary of the key numeric columns in the Titanic dataset, showing counts, means, and ranges that help us understand the data's scale and completeness. Notice, for example, that the age column has fewer entries than others, indicating missing data, while the survived averages around 0.38, meaning about 38% of passengers survived. This overview guides our next steps in cleaning and analyzing the data effectively. Notice which columns have the largest range of values. Basic data selection, columns and rows. You can select columns and rows in several friendly ways. Let us try selecting specific data. Running the cell now. Imagine picking out just age and fare information across all passengers. Let us focus on just one column. The comment shows we want only one column. We select the age column and store it as a new variable, which is a Pandas series. We glance at the first few ages so we know what they look like. Running the cell now. Here, we've selected the age column from the DataFrame, which returns a series showing individual ages. Notice the output lists the first 5 entries with their index labels, highlighting how selecting a single column isolates that data for easy analysis or manipulation. This demonstrates the simplicity of column selection in Pandas, a key step in data exploration. If you type ages.shape, you will see that a series has just one dimension. Often, you care about more than one piece of information at once. This line tells us we want several columns. We choose 3 columns and get a new data frame with only those details. We take a quick look so we can check the selection worked. Running the cell now. Here, we selected 3 specific columns, survived, sex, and age, from the original data frame to create a smaller subset. Notice how the output shows just these columns for the first 5 rows, allowing us to focus on key features without distractions. This demonstrates how you can easily narrow down your data to the most relevant parts for analysis. Try putting your own list of columns between those brackets. Let us explore both rows and columns at the same time. The comment reminds us that LOC is for selection by labels. We pick the first 5 rows, and only the name, p-class, and survived columns. Running the cell now. This output shows a slice of the data frame, displaying the first 5 rows with only the name, p-class, and its survived column selected. Notice how the .loc method allows us to specify both row indices, 0 to 4, and chosen columns, making it easy to focus on key information like passenger class and survival status. This demonstrates how to retrieve specific, relevant data efficiently for analysis. Remember, LOC includes the end index. Try slicing other ranges to practice. Now, use positions, not labels. The comment shows that iloc means you pick by row and column number like a matrix. We take the first 5 rows and the first 4 columns using numbers. Running the cell now. Here, we use iloc to select the first 5 rows and the first 4 columns of the data frame, focusing on numerical index positions. Notice the extracted subset includes key columns like passenger ID, survived, and p-class, along with name, which helps us verify we are correctly slicing rows and columns by position. This demonstrates how to quickly access specific parts of your dataset by row and column indices. What happens if you swap the start and end numbers? Let us tidy up. Data cleaning, handling missing values. Real data is messy. Pandas makes it easier to handle missing values. You will quickly check for and fill in missing data. Running the cell now. Missing values are common in real-world datasets. Do you see any here? Let us see where values are missing. We use this comment to ask what is missing, column by column. Pandas will show how many missing values each column has. Running the cell now. Here, we see the count of missing values in each column of the dataset. Notice that the age, cabin, and the embarked columns have significant missing data, especially a cabin with 687 missing entries. This tells us where we need to focus our data cleaning efforts to handle incomplete information before further analysis. Can you pick a column with the most missing values? You will fill missing ages using the median. Our comment shows how we want to deal with missing age values. We find the median value of the age column. The median is the middle value. Now, fill in the missing age spaces with this median value for a more complete set. Let us check if there are any more missing ages left. There should be 0. Running the cell now. The output 0 confirms that all missing values in the age column have been successfully filled using the median age. This is important because it ensures no gaps remain in the data, which could otherwise cause errors or bias in analysis. The intent here is to demonstrate how to handle missing data efficiently with Pandas to maintain dataset integrity. Try changing in-place equals false and see what happens to df. Sometimes we would rather remove rows that have empty values in important columns. Our comment describes dropping rows with missing port of embarkation values. We delete rows where embarked is missing. This helps keep data clean for analysis. We print the new shape to see if the number of rows changed. Running the cell now. Here, we use dropner to remove rows where the embarked column had missing values. Notice the output shape, 889, 12, shows the dataset now has 889 rows, down from the original 891, meaning just 2 rows were dropped. This confirms how dropner helps clean the data by eliminating incomplete entries in specific columns. See if the number of rows is now smaller than before. Filtering data, conditional selection. It is often useful to focus on certain passengers based on rules. Let us practice creating smart filters. Running the cell now. Can you think of a way to filter all passengers over age 60? Let us try filtering for a specific group. This comment says we want to look at women only in the data. We create a new data frame with only the rows where the sex is female. We print the shape to see how many females are there. Glance at a couple of rows to confirm this filter. Running the cell now. This output shows that filtering the dataset to include only female passengers results in 312 rows and 12 columns, focusing our analysis specifically on females. Notice how the dot head displays key columns like survived, P-class, and age, which are crucial for understanding survival trends among women in the dataset, exactly what the filter was intended to isolate. Try changing female to male and see if numbers match your guess. Now, focus on those who paid a high fare. The comment explains we want higher fare passengers. We filter so only rows with a fare above 100 stay. We show their names and how much they paid. Running the cell now. Here we see a filtered list of passengers who paid more than $100 for their fare, showcasing how conditional selection extracts specific rows based on our criteria. Notice the fare values are all above 100, demonstrating that our filter correctly isolates higher-paying passengers, which is useful for targeted data analysis or insights. Do you notice any connection between fare, name, and class? Let us try more than one condition at a time. The comment helps us remember we want young boys who survived. We filter the data frame where the gender is male, the age is less than 18, and they survived. We print out their names, ages, and survival info. Running the cell now. This output shows a filtered list of young male passengers under 18 who survived the Titanic disaster, highlighting key columns like name, age, and survived. Notice the consistent survival value of 1, confirming the multi-condition filter worked as intended to isolate this specific group. This example reinforces how combining multiple conditions helps us focus precisely on relevant subsets of data for deeper analysis. Try changing ages or survival values to get different groups. Group by and aggregation, summarize by groups. Let us see summary statistics for different passenger groups. Grouping helps you find patterns. Running the cell now. Which group do you think has the highest average fare? Let us try splitting up the data by ticket class. The comment previews that we will compare groups by class. We group rows by P-class and then get the mean, average, fare for each group. Running the cell now. This output shows the average fare paid by passengers in each class, revealing a clear trend. First-class passengers paid the highest fares on average, followed by second and third class. Grouping by EP class and aggregating with the mean helps us quickly summarize fair patterns across different groups, illustrating how group by can uncover key insights in your data. Notice that first-class tickets cost more. Why might that be? This time, let us group on two columns at once. The comment lets us know we are counting within groups. We first group by both gender and survival, then count the number of people in each category. Running the cell now. This output shows the count of passengers grouped by sex and survival status, revealing key patterns: more females survived, 231, than died, 81, while a larger number of males died, 468, compared to those who survived, 109. Notice how grouping helps summarize the relationship between gender and survival, which is essential for understanding passenger outcomes in context. See which group had the highest survival count. Let us combine several measures at once. This comment explains we want more than just an average. We group by sex and then show mean, median, minimum, and maximum age in each group. Running the cell now. This output shows key age statistics: mean, median, minimum, and maximum, for passengers grouped by sex. Notice how the average age for males is slightly higher than for females, while medians are the same, indicating a similar middle age but a wider age range for males. This highlights how Group B with aggregation helps uncover differences and patterns within categories. You can add other statistics in the list inside Ag. Merging and joining, combine data frames. Suppose you have two tables. Pandas makes joining easy. Let us join a data frame of passenger titles to our Titanic dataset. Running the cell now. Joining helps when columns are split across multiple sources. Let us make a tiny data frame to use for joining. Create a comment explaining that we're making a simple lookup table of titles. Start creating a new data frame called Titles using Pandas. Assign to the name column the first four entries from this name column of DF. Assign to the titles column a list of common passenger titles corresponding to those names. Print the titles data frame to display its contents. Running the cell now. Here we have created a small lookup table with the first four passenger names and their corresponding titles. Notice the two columns, named contains full passenger names, and the title holds simplified titles like Mr. and a Mrs. This setup is key for the next step, merging these titles back into the main Titanic dataset to enrich it with more structured information. You can practice by changing the titles or picking different rows. Now, let us combine our main data frame with our new one. The comment says we want a left join. This means everyone from Titanic data stays. We merge the two data frames based on the name column. Panda adds title info if there is a match. We show the first few results to see the title info added. Running the cell now. This output shows the result of a left join, where the title column from the titles data frame is merged into the main Titanic data frame based on the name column. Notice that for some passengers, like Alan, Mr. William Henry, the title is missing, Nan, indicating no matching entry in titles. This highlights how left joins keep all rows from the original data frame while adding matching information where available. Notice there are lots of missing values in title since we only added it for 4 names. Reshaping, pivot tables. Pivot tables help you summarize and compare groups in a table format. Let us see how many survived in each class and by sex. Running the cell now. Pivot tables are very powerful for finding patterns across many variables. Let us summarize how survival counts compare by class and sex. This comment explains that we are creating a pivot table to analyze survival by class and sex. We create the pivot table from the data frame, using a passenger ID values to count. The rows of the pivot table are grouped by passenger class, P class. The columns of the pivot table are grouped by passenger sex, sex. We used counts as the aggregation function to tally the number of passengers in each group. We print the pivot table to display the results. Running the cell now. The pivot table clearly shows the count of passengers who survived, broken down by passenger class and sex. Notice the increasing number of males and females as we move from first to third class, highlighting how survival varied across these groups. This demonstrates how pivot tables effectively summarize and compare group data in a compact format. Try changing which variables go across columns or rows. Visualizing with Pandas, survival counts. A quick bar chart helps you see differences across groups. Let us visualize survival by passenger class. Running the cell now. What other columns would you like to visualize? Let a picture tell the story. The comment tells us we are about to plot a bar chart. We import matplotlib so we can show charts. We calculate the mean survival for each class and plot the result as bars. We label the vertical axis for clarity. We give the chart a clear title. We show the plot right away so we can see the result. Running the cell now. This bar chart shows the average survival rate for each passenger class on the Titanic, highlighting clear differences across classes. Notice how first-class passengers have a higher survival rate compared to second and third class, which aligns with the lesson's goal of using visualizations to quickly compare group statistics. This confirms that grouping and plotting with Pandas effectively reveals key trends in categorical data. Notice which class had the highest survival rate. Mini-project exploratory data analysis. Let us try a short challenge. You will investigate age, fare, and survival. Practice analyzing and plotting. Running the cell now. Pause the video and write code to find the average fare for passengers older than 40. This plot shows two important features and highlights survival. The comment describes our goal, a scatter plot. We set the plot size so everything is easy to see. We pick colors, red for did not survive, green for survived. We plot each passenger's age and fare, coloring by survival. We add a label for the age axis. We label the fare axis. We give the plot a clear, descriptive title. We show the finished chart. Running the cell now. This scatter plot shows how passengers' age and fare relate to their survival, with green dots for survivors and red for non-survivors. Notice survivors tend to pay higher fares and are often younger, highlighting potential factors influencing survival chances. This visual helps us explore patterns in the data and prompts questions for deeper analysis. See if survivors or non-survivors tend to cluster together. Try changing the axes or colors. Let us talk about habits that save time and bugs. Best practices and performance tips. Keep code readable, use comments, clear variable names, and meaningful column names. Use vectorized pandas methods, not loops, for speed. Always check your data before and after cleaning. Running the cell now. What mistake do you make most often? Try typing an example and solve it in Pandas. Let us see how to use vectorized operations for calculation. The comment explains the lesson, avoid loops by using Pandas column math. We make a new column by squaring every fare value all at once. This is fast. We print the first few rows to see the new squared values. Running the cell now. This output shows the original fare values alongside their squared values in the new fare squared column, demonstrating vectorized operations in Pandas. Notice how the code efficiently applies the power operation across the entire column at once, avoiding slower row-by-row loops and improving performance while keeping the code clean and readable. Try making another new column based on age using just one line. Common issues and debugging in Pandas. Watch for typos in column names. Pandas will give a key error. If code is slow, check if a loop can be replaced by a vectorized method. When in doubt, print your data frame's shape and head. Running the cell now. Had a weird pandas bug? Try printing the first few rows to spot the problem. Let us trigger and see a common error. Our comment warns this will cause an error. We use try so that if something breaks, we can catch it. We try to print a column that does not exist. There is a typo. If a key error happens, we handle it and print the error message. Pandas throws the error because ag is not an available column. Running the cell now. This output shows a key error because the code tries to access a column named ag, which doesn't exist due to a typo. Notice how Pandas immediately flags this mistake, helping you quickly identify and correct misspelled column names. This reinforces the lesson's point to watch for typos, as they are a common source of errors in Pandas. Practice, intentionally type a wrong column name and see how Pandas responds. Let us fix a column name cleanly. The comment says this is about renaming. We call rename with a dictionary for any just added columns. We check the columns, looking for the updated name. Running the cell now. Here, the output shows the updated column names after renaming the fair squared to fair_squared, demonstrating how to safely fix typos in column names. Notice the new to fair_squared column appears correctly without causing a key error, highlighting the importance of precise column names in Pandas for error-free code execution. Column names can include underscores or spaces, but be consistent. Challenge yourself. Try these. 1. Find the youngest and oldest passenger in each class. 2. Create a histogram of fares. 3. Make a new column flagging passengers as a child if age less than 13. Pause and try them yourself. Running the cell now. You are ready to explore your own datasets with Pandas. Let us reflect on your progress for a moment. Recap. You learned to load, explore, clean, join, and visualize data with Pandas. These skills help you work fast and ask deeper questions about real data. Keep practicing and you will master Pandas. Running the cell now. Can you explain to a friend what a DataFrame is now? Thank you and next steps. Thank you for learning with us. Subscribe for more lessons and leave your favorite Pandas tip in the comments. Practice, experiment, and you will soon be a Pandas pro. Running the cell now. What would you like to learn next? Share below and do not forget to like and subscribe.